So we will now go on with the next presentation, which comes from Anders Giebeck from the company SICK. And Anders will give us a talk about machine vision beyond the traditional limits. And we are looking forward now for your presentation.
Thank you. So, it seems like. So thank you all for being here. My name is Anders Giebeck, Strategic Product Manager at SICK, working with machine vision solution, especially our deep learning technology. So SICK has been innovating sensors and industrial automating for decades. And we had a vision to make deep learning easy to use and accessible to our customers. And what I'm going to present to you today, in my opinion, we're taking a big leap in that vision. Is this working? Which one is it? Here we go. So let's start with just with a real customer case. We had a customer with a problem. He wanted to automate his process. He wanted to automatically classify or sort Euro pallets between e-pallets. If we use traditional rule-based machine vision, you can think about maybe using a pixel counter to look at the bright and the dark pixels. Maybe you could do some kind of measurements on the label. Maybe you can do that. Or you can do like an edge counter or edge locator or OCR. But what if the pallets look like this? It's like impossible to do it with traditional rule-based, or maybe very difficult or time-consuming. So this is really where deep learning comes in, to like train a system with images or example images to make the life much easier. So basically, deep learning gives us the possibility to solve complex machine vision applications where rule-based were not possible to do it before. So these are some of the applications that I'm going to talk about today. But to start off, I just want to show you a quick video where we're presenting our exciting new products. Yeah, so I think you're all awake now after this song. So what we have developed is a sensor app that we call SICK Nova that enables deep learning powered tools in it. And it runs on the device. So it's a smart camera, or with other words, where you can run the deep learning tools directly on the camera. So this provides a really cost-efficient ownership as the deep learning tools runs on the camera. So no need for external PCs or controllers. It can be run directly on the device. Yeah. And what I'm especially excited about is our new anomaly detection tool. It can detect anomalies that are present in the image somewhere. And it presents a heat map of where the defect is detected. And it gives us the possibility to only train on the good images. The bad images are saved for evaluation purposes and threshold making. But the cool part is they can do the labeling, training, and evaluation directly on the device, which is great. And it gives the user the possibility to solve complex applications, such as soldering, welding, label inspection, things that are unpredictable. And this really gives the possibility and provide benefits to our customers, for example, reducing waste and improve productivity and improve yield. And this is a little bit how it looks like. So we have a configurable GUI drag and drop interface, very easy to use, that runs, as I said, directly on the device. You have the possibility to collect images directly in the tool. So we have a tool pane to the right-hand side where you can collect images, handle the data sets, you can label images, train and evaluate everything on the tool pane to the right-hand side. And here you can see where we collect images, and they're collected directly to the correct label here. And you can save the image directly to the memory or the SD card on the device, or if you want, you can save it to the PC as well. And here you can see like the dialog on where you do the labeling. So if you want, you can manage the complete data set directly from the device as well. You can change labels, and you can label labels that have not yet been labeled. And here you can see where after you have done the training, you can also get some evaluation dialogue where you can set the threshold for the anomaly scores, etc. And you can visually see how the training performed. And as I said, also the training is also performed directly on the device. You can choose with a slider if you want a high accuracy of the tool or if you want to have a fast execution of the tool. And we have optimized that for you. So each image gets a score, and you can set that threshold directly from the GUI. And this is now how it looks like when it's executing directly on the device. So here you can see like a defect was found on the connector pads on the SD card. Now these are some examples of applications you can do. So it's suitable for deformable objects, such as packages. Since packages vary a lot, then it's very suitable to use in deep learning this type of applications. Another example is when you have like unpredictable defects. You can see here the lid is broken or the flap is up on the right-hand side. This is also something that could be solved with the anomaly detection tool. Also within the electronics, you can see here a soldering here that have a short circuit on the solderings here. This is also something that's suitable for deep learning, especially the anomaly detection tool with unpredictable defects. And as I said here also, when you have reflective materials, such as the connector pads, this is also especially good because these images are taken by a camera with built-in illumination. And usually you want to have a quite complex or expensive illumination, but using deep learning technology, you can actually reduce the need for a more expensive illumination, since you're training the complete different ways how reflection could look like in the training set. Another application example is with the labels, so detect defects on labels. So that's also another good application for this tool as well. The other tool that we also have is the classification tool, where of course you have the possibility to sort and classify objects. And this tool instead is trained on a similar amount of images from all the classes. Here we do the labeling and evaluation in the cloud in something called DStudio, which is a cloud-based training service that we use. But with the classification tool, we have the possibility to solve complex classification tasks or defect classifications. This is how it looks like here when you collect images. So in this case here, we collect images directly to the PC. And after you've done that, you can then upload all your images to our training service, DStudio, where you can do the labeling, the training, and the evaluation in the cloud. And when you're happy with the result from the cloud service, you can then download the model and upload it to the camera, and then you can execute the classification tool on the device. And some of the cases that are running right now with this tool is within these washing machines that they want to wash used or new glass. And these machines have different settings, but depending on what type of glass it is. Before there was a manual operator standing here adjusting the settings. But now with our solution, they can automatically change between the settings to optimize the water flow automatically. And this is another application where deep learning is very suitable. We have reflective material. We have slight variations within the class. Another application that is running right now with our solution is within the wood industry. Deep learning is very suitable for organic material in general, since they all look different. So in this case, they're using our solution to flip the planks before other processing steps further down the line. So they want to make sure that the plank has a certain direction. So our solution is looking into the structure of the annual rings and then classifies if it's just flipped or not. So these are some examples that is being used right now. Another big benefit with our solution that we come up is that you can combine the benefits with deep learning and rule-based vision side by side. So you can see here in this picture here, we're using an object locator to first locate SD card, and then as a parent, and then we have the anomaly detection tool as a child of the object locator. So here we have the benefits of two worlds at the same time, the accuracy and the speed of the object locator, traditional rule-based, and then the example-based approach with deep learning side by side, which is great. And what I told you earlier, we have two ways how to train and evaluate. So either you can do it on the device itself. At the moment, this is only possible with anomaly detection, but we're improving it. Very soon, we're going to be able to do classification as well on device training. Or if you want to optimize accuracy, you can go to our cloud training service, DStudio. So you can do it either on the device or in the cloud. So to really sum up what I talked about today, with deep learning gives a lot of benefits. You can solve new type of applications that were not possible to solve before. And with these new two tools we have that can run on device, the customers can have lots of benefits to their production facilities. And it gives a lot of cost-efficient benefits to have it run on the device itself, because you can save cost on the controllers, external PCs, etc. And with the possibility to do the training on the device, it saves a lot of time in this process. That could be quite cumbersome, working with lots of images, but since we can do it now on the device, you can stay on the device, work from the device. Someone before here said we can solve an application within 5 minutes when you installed it. Yeah, so I'm really looking forward to speak to you in the booth. That's in the other hall, hall 10. And I look forward to speak with you. So if you have any questions.
Okay, thank you very much. Anders Giebeck from the company SIG. Are there questions? Please feel free to ask. So actually, I have a question.
Oh, thank you.
Can you specify a little bit more what's in the cloud and what's on the device?
Okay,
and how much additional hardware to train and learn do you maybe need? And maybe you can point that out a little bit more.
What we have in the cloud is a training service for classification right now. But we are improving this step by step. So we're going to more and more things are going to evolve in the cloud.
Yeah.
So there you only do the training, elevation, and training, and the labeling. On the device hand side, we can do everything. In terms of the anomaly detection tool. Mm. So there are, for example, if you want to work with anomaly detection, then you only need one of our cameras, smart cameras. That's the only thing you need to know. Mm. But if you want to work at the moment with classification, you need a camera, but you also need to access our cloud service.
Ah, okay. Okay.
Yeah,
okay.
But what I've said is that coming very soon, we're going to have the possibility to also do classification on the device. And I also really look forward to present that tool to all of you when it comes.
Okay, and we are looking forward to that. Thank you.
Yeah.
Are there other questions? If this is not the case, thanks again for the presentation.
Thank you.